In this video, we will walk through the full starting workflow for an EVE5 display, from hardware bring up and the minimal initialization example, throughout quick UI prototyping in the EVE screen editor, to the software ecosystem and reference projects provided by Bridgetek. If you want to check out the difference between EVE5, EVE4 and other older versions, all you have to do is visit Bridgetek website. You can see here that for the EVE5, not only the supported display resolution is higher, but there are also external memory support, much more GPIOs, and direct video input for LVDS Full HD in 60 frames per second. Here you can see the size difference between 15.6-inch EVE5 and 10-inch EVE4. Okay, let's start with the hardware setup. Here in the middle we have the Riverdi 15.6-inch Full HD EVE5 display. From the top left corner you can see ST-Link V3, Riverdi evaluation board, both connected with female-to-female jumper wires, a rebus cable to connect STM from evaluation board to the display, and to power it up, I use standard 12-volt power supply. Let's move to the software development. To confirm that the hardware and communication are working correctly, we start with a minimal C example opened in STM32Cube IDE. This example initializes the EVE5 display and loads an image directly from an SD card. The goal here is not to demonstrate a full application, but to verify that the display initialization, memory access, and graphic pipeline are working all as expected. Once the image appears on the screen, we know that the display is properly initialized and ready for the further development. At this point, we have a clean and confirmed starting state for building our own user interface. With the display initialized, we can move to rapid UI prototyping using the EVE screen editor. When you open the screen editor, you already have access to a number of ready-made examples. For this demonstration, we will start with a simple gradient background. This provides a clean visual base and makes changes easy to see on the real display. The connected board is detected as a single RS232 device. After selecting it, we choose the VM820B 15B preset, which matches the configuration of the Riverdi 15.6-inch EVE5 display. Once connected, we can program the device directly from the screen editor. The display list generated by the tool is written to the EVE, and the result appears immediately on the screen. Now let's extend the example by adding a widget. We place a spinner in the center of the screen, adjust its style and scale, and program the device again. The updated interface is visible immediately on the display. This kind of iteration takes only seconds and allows you to quickly validate layout and visual design without writing application code. This is the core idea behind the EVE screen editor: visual UI prototyping, automatic display list generation, and instant feedback on real hardware. At this point, there are a few different directions you can take, from deeper UI design to firmware integration. If you would like to see a deeper dive into one of the EVE tools or workflows, let us know which one would be the most useful for you. For firmware development, Bridgetek provides a complete set of reference projects on GitHub. The official repository contains examples for EVE5, including bitmap handling, widgets, and demonstration applications. A typical workflow is to start from one of these reference projects and adapt the display init parameters to match your specific panel. Once initialization is correct, you can build your own application step by step on top of these examples. If you want to learn more, check out useful links in the description of this video. Thank you for watching.